This lesson is an introduction to the simplex method of solving a maximization problem. So we've looked at how you can use linear inequalities and you can graph them and find a feasible region and then find the corners of that region and test all of those to see what will maximize a particular objective. And that method is great, but it can be not so easy to do. Okay, so we had a few problems where you had to solve a system to find a point where two the inequalities would intersect each other. Sometimes you just don't get nice points by graphing, and then it adds a lot of extra work. So the simplex method is a method that you can use as an alternative to find those points and maximize your problem. Okay, so you'll notice from the title of this lesson that we are not going to actually worry about solving in this particular video. It's just an introduction to the simplex method. So the goal here is that you're going to be able to set up a problem and then interpret what the solution means. And we're going to skip the actual solving process for right now. That'll be in the next video. Okay, so what you're going to do, step one, is if needed, you're going to define the variables for your situation and write the objective and constraint functions. That's not going to apply in something like example 1 that's already given to us. That's more of like a word problem like example 2. Okay, so that's step 1. Step 2 is that you're going to convert each of your constraint functions into an inequality by adding what is called a slack variable. Okay, and we're going to come back to that just in a minute and talk about what is a slack variable. All right, so after you do that, you are going to set up your initial simplex table. Okay, AKA a matrix. It's a type of matrix, but it's specifically called a simplex table. Step 4 is where the solving happens, and for right now, like I said, we're going to skip that. We're just going to say, oh, look, a magic process, and then move on, okay? So then step 5 is you need to be able to read the solution from the final tableau. Great. Okay, so let's look at this example. So we have an objective function here that we want to maximize, and then these are our different constraints. So we can skip step 1. That's already kind of been done for us. So that's not a big deal. So we're going to convert each of these inequalities into equations. And that was silly of me. I just realized that I wrote inequality here, and I meant to write equation. Go back and fix that. Okay, so convert each constraint inequality into an equation. They're already inequalities. Okay, so what I'm going to do, we got this equation right here, 2x plus y is less than or equal to 4. Okay, so here's kind of the thought process here. When we have an equation, let's just do something a little bit simpler. Let's say x is less than or equal to 4. Okay, so we have this inequality. X could be equal to 4. It could be less than 4. If x is less than 4, right, then that means that there has to be some number that when you add it to x will make it actually equal 4. Okay, so for example, if x was 1, 1 is less than or equal to 4, and I could add 3 to it to make it actually equal 4. Okay, if x was 0, right, then I could add 4 to it to make it equal. Okay, so we're converting this by adding something right here, and this number right here is going to change depending on what your value of x is, right? So we're going to use a variable for that, and it's something that we call a slack variable, okay, because it's a variable because we don't know what it is. It's changing depending as x changes. And it's a slack variable because it's picking up the slack to make x equal to 4. Okay, so this is what we're going to do with these inequalities right here. So I'm going to take this first inequality, and I'm going to rewrite this with a slack variable. So I'm going to have 2x plus y, and I'm going to add in a slack variable. And the variable I'm going to use for that is I'm going to use s sub 1, because we're going to have more than one slack variable. Okay, so I'm adding the slack variable, and when you add whatever that slack variable is, that is going to make your inequality into an equation. So now it's actually going to equal 4. Okay, the second inequality, we're going to do the same thing. I'm going to add negative x plus 2y, and then I want to add a slack variable to this. But it can't be the same slack variable as we used here, because this is a totally different set of numbers, right? It's a totally different value here than what it was here. Okay, so the amount that I'm going to have to add to get it to equal, again, 4 in this case, is going to be different. So I'm going to add s sub 2, a second slack variable, and that's going to make this equation into 4. All right, and then these last two pieces here, so x is greater than 0 and y is greater than 0, we're actually going to mostly ignore those until we get to the end, and then just make sure that our solutions at the end hold those true. There's such simple inequalities to deal with, like we're just strictly saying it's got to be greater than or equal to 0. That's so easy to deal with at the end. We're not even going to bother dealing with it in our big table. All right. And then the last piece that we have to do is we have to take our objective function, and we're going to rewrite this a little bit as well. So we want to have this inequality here kind of match up. I'm sorry, it's an equation. This equation, we want it to kind of match up with these guys. So see how on these ones we got the x and y over here, and it's just a number, a constant on this side? Well, we want to do the same thing over here. We want x and y and z all on the same side so that it'll just equal a constant. Okay, and also importantly, we want z to remain positive. So what I'm going to do with this equation is I'm going to rewrite it. I'm going to subtract the 3x from both sides and subtract the 4y from both sides, right? So I'm taking z equals 3x plus 4y, right? I'm subtracting the 3x from both sides. So then I have negative 3x plus z equals 4y. And then I'm going to subtract the 4y from both sides. And I'm going to put these in alphabetical order. So negative 3x minus 4y plus z equals 0. There it is. All right, so that's kind of what I'm doing, but I kind of just do it all in my head. I don't bother to do all the steps out. So I just look at it and go, oh, okay, well, I move the 3 over, it becomes a negative 3. Move the 4 over, it becomes a negative 4. And then plus z equals 0. All right, so we now have our equations here, right? And we've got an equation that's in kind of the same format. Great, so now we are going to make our simplex table. All right, so this is going to look a little bit like a matrix because it is a matrix. All right, so what I'm going to do to start with is I'm just going to start by making a list of all the different variables that we have just so that I can kind of keep track. Okay, so the different variables we have an x and a y. This first equation, we added an s sub 1. This equation, we added an s sub 2. And then this equation, we also had a z. All right, and then I'm going to do kind of a vertical line here where I'm going to break this. And over here, sometimes people put a c, sometimes they don't put anything, but that's for just our constant, right? That's the number that our problems equal. Okay, and this is just going to kind of help us line up. So what I'm going to do is I'm going to take these values and I'm going to plug them into my matrix, just kind of making sure things stay lined up. So this first equation, I have 2 x's and 1 y. So 2 x's, 1 y. This is a 1 s1, so there's one slack variable. There are no s2s in this equation. There are also no z's in this equation. And then my constant is 4. All right, now I'm going to do the next equation. This one has negative 1x and 2 y's. So negative 1x, 2 y's. There are no s1s in this problem, so 0. But there is one s2. And there's no z's in this problem. And the constant is 4. All right, and then similar to how we use this vertical line to kind of split the two sides of our equations, we're going to add in a horizontal line to split our two types of equations, right? So we've got, these are our constraint functions, and we're going to put the objective function at the bottom. So this one has negative 3x minus 4y, right? There's no slack variables of either type. There's one z, and it equals 0. Okay, and then I'm just going to add my brackets around this. Made my vertical line go a little bit too far, no big deal. And that is your simplex table. Okay, so it's pretty easy to set up. You just have to really, I really find writing these variables along the top really helps because that just kind of helps me keep track of where everything is. All right, so we've got our table set up. So this is where the mathemagic happens. And we will learn how to do this. That's going to be our next video. But for right now, we're just going to let the mathemagic do its work. All right, and I'm just going to tell you that after you do this, here's the answer that you're going to get. Okay, so I'm going to kind of read these numbers going across by row. So if you want to try to write them down as I say them, great. If not, feel free to pause the video and go back and copy it. So first row across is 1, 0, 2/5, negative 1/5, 0, and then we got our vertical line for the answers, and 4/5 is what's on the other side there. Second row is 0, 1, 1/10, 1/5, 0, and then on the other side 12/5. And then I got my horizontal line going across to break off my objective function. And that is going to be 0, 0, 2, 3, 1, 12. Okay, so that is after we finish solving, that's what our simplex table is going to look like. Okay, so what does this give me? Well, now I'm going to be reading my solutions off of this. So what's happening here? Well, remember, this is x, this is y, that's my slack variable 1, slack variable 2, z, and this is just my constant. Okay, so what's happening here? Well, these slack variables, remember, these were just something that we added in so that we would have, instead of an inequality, we'd have an equation, right? They don't actually exist in our original problem, right? We added that in as a little extra piece. So in terms of solving our actual system, these slack variables really don't matter. Like, it worked out that, okay, these are the amounts that we're going to be adding in, great. Like, those are the extra little pieces that are going to make it actually equal 4, right? So that's wonderful, right? But I don't really care, because in the end, I didn't actually need it to equal 4. I just needed it to be less than or equal to 4. Okay, so I'm going to basically just ignore these slack variables. And when you ignore them and you kind of read across, just like in a matrix, you can see this top equation now becomes 1x plus 0y's, ignoring the slack variables, and 0z's equals 4/5, right? So that just simplifies to x equals 4/5. Right? And then in the second equation, we've got 0 x's and 1 y, ignore, and 0 z's equals 12/5. Well, that tells me that y is 12/5. And then this bottom equation, 0 x's, 0 y's, ignore, 1 z equals 12. So z equals 12. So that right there, that is our solution, okay? These are the values. So these two are the values of x and y that you would need to meet all of these equations. And then this right here, right, that is the maximum value of our objective function. Okay, so that's the maximum value of our objective function. So the highest value that you can get out of this equation is 12. Okay, and that happens when you're at these values for x and y. All right, great. So we kind of saw the process. Now I want to look at this word problem, because I think that it's going to make it just a little bit more clear about what's going on in this problem if you kind of look at it in a situation. Okay, so that's kind of our next piece. I'm just adjusting this camera a little bit. I don't know if you're getting the gray flashy things on the screen. I'm hoping not, but it keeps giving me gray flashies, so I'm trying to make it so it stops doing that. All right, so we got this one. We got an office manager. He's buying new filing cabinets. This one kind of cabinet, they cost $40 each. They require 6 feet of floor space just to hold the cabinet. And then the cabinet themselves, you can put 24 cubic feet of files in. Different brand costs more, requires more floor space, but they also hold more files. So this guy has $560 to spend. Okay, but he can only hold 72 square feet of cabinet spaces in this actual office. So we want to know how many of each type should he buy so that he'll be able to get the greatest storage space possible. Great. Okay, so step one, we need to define our variables. What are we actually looking for here? Well, they're asking us how many of each type of cabinet he should buy. So that's going to be what our variables are. I'm going to use x and y just to kind of keep consistent here, rather than trying to use like maybe A and E or something like that. So X is going to be how many, so the number of ace cabinets. And then Y is going to be the number of excellent cabinets. Okay. All right, so from here, I'm going to try to start writing some equations and inequalities based on that information. So my first equation, right, or first of all, I want to kind of worry about, well, what is my objective function going to be here, right? So they told us we want to know how many of each type of cabinet, and we want to achieve the greatest storage space possible, right? This right here, the storage space, that's what I'm trying to maximize, right? So when I write my equation for z that I'm trying to maximize, my objective function, right, I'm going to want this to maximize storage space. So let's go back through here. What do we know about storage space? right? Well, this is the cost. This is how much floor space. This is how much they're actually getting for storage, right? This was a cost, that was floor space. Here's the other one, right? So those two values are talking about the storage space, right? Which is what we want to maximize. So that's what my Z equation is going to be. So how do I calculate the total? Well, you get 24 cubic feet for every ace cabinet for every X. So you get 24 cubic feet per X. And you get 36 cubic feet per excellent cabinet, or Y. So 36 cubic feet per Y. And if I add those together, that'll give me the total amount of storage space that I get. Okay, so that right there is going to be my objective function. All right, so what about my constraint functions? So then my constraint functions, well, what else do I know? I know that each of these cabinets has a cost and that I can only afford so much. So that's a constraint, right? That's a limit on what my options are. So the fact that this one costs $40 and this one costs $80 and I only have $560 is going to be my first constraint function. So I'm going to spend $40 per ace cabinet. And when I add that to the $80 per excellent cabinet, that needs to be less than or equal to $560. I can spend all $560 or I can spend less. You just can't spend more. Okay, and then my other constraint is the fact that I am limited on how much floor space I have available, right? So this one requires 6 feet of floor space. This one requires 8, and I only have room for 72. So 6 feet per ace cabinet plus 8 feet per excellent cabinet needs to be less than or equal to 72 square feet. All right, and then there's also an assumption here that you also have the same restrictions that we had here, where X and Y both have to be greater than or equal to 0. I kind of forgot to go back to that with this example, right? Just kind of do a check at the end. Yeah, they're both positive, so we're good. We met those constraints and we're all set. The same thing's going to be true here, right? And that totally makes sense because you can't buy negative file cabinets, right? If X and Y are file cabinets, right, you can't have a negative number of file cabinets. That doesn't make sense, right? So strictly speaking, X and Y both have to be greater than or equal to 0, but I'm not really going to bother to write an equation for that. I'm just going to kind of use that as like a, oh yeah, duh, at the end. Okay, so now I'm going to convert all of these guys into our different equations. So this guy right here, right, I'm going to rewrite him where I want to get everything all onto one side, right? So this guy, I'm not getting it all on the one side. That's what we're going to do here. I want to add my slack variables to make this an equation. Okay, so I'm going to take 40x, add 80y, and then I'm going to add in my slack variable, s sub 1, to make it equal 560. Okay, this equation here, I'm going to do the same thing. 6x plus 8y, I'm going to add in a different slack variable to make it equal 72. Okay, so we've converted both of those. As just sort of a side note with these, another option that you have before you add your slack variables, if you wanted to, is you could take this whole equation and like divide everything in here. Like this will simplify pretty nicely. We could divide everything by like 10, and then you'd be down to 4x plus 8y is less than or equal to 56. Right, and then you could actually even divide that further by 4, right? So if you do that, it'll give you some smaller numbers sometimes, which just can make your life a little bit easier. I'm not stressing about it too much in this problem, just because like we're not really worrying about solving in this one. We're just sort of worrying about the setup. Okay, so we've got that. And then one more thing we have to do is we're just going to rewrite this objective function. I want z to remain positive, so I'm going to move these guys over to that side. So that's going to become negative 24x minus 36y plus z equals 0. Cool. All right. So now setting up our simplex table. So that's my next step here. So I'm going to set up my simplex table. I'm going to write out all my variables just to help me out. I've got an x and a y. I have an s1 and an s2 and a z. And then that's it, right? The last thing's my constant, which you can write a c. If you don't want to write a c, that's cool too. All right, and then I'm just going to fill in these numbers. So filling these guys in, first equation, I've got 40 x's and 80 y's. So 40 x's, 80 y's. I have one slack variable. I don't have any slack variable 2's. I don't have any z's. And then it equals 560. Okay, second equation, I have 6x and 8 y's. There's no s1's, but there's one s2. There's no z's, and it equals 72. And then there's the line that splits this from my answers. And then this guy goes in the bottom, right? So this is my objective function down the bottom. I've got negative 24 x's. I've got negative 36 y's. There's no slack variables at all, but there's one z, and that adds to 0. And there's my awesome table. Great. Okay, so we're almost there. So this is the part, again, we're not worrying about solving this just yet. We're going to come back to that later. So for right now, we're just going to say that that's where the magic happens, right? And we're going to transform this, and our new matrix, which again, I'm going to read across if you want to copy it as I say it. The first row is 0, 1, 3 halves, negative 1 half, 0, 3. Next one is 1, 0, negative 2, 1, 0, 8. And then the bottom row is 0, 0, 6, 6, 1, 300. Okay, and then I'm just formatting that, adding my lines in where they go. All right, so now from here, you just need to be able to read your answers. All right, and you might be tempted to say, oh, x is 3 and y is 8. But that's not actually true, right? Because remember, this is x, this is y, slack 1, slack 2, z, and our constant, right? When we look at these equations here and what information they actually give us, in this top row, it's saying that there are no x's and there's one y. And then we're kind of ignoring our slack variables. So this top equation actually says that y is what equals 3, right? So y equals 3. This equation is telling me that 1x equals 8. And then the bottom equation is telling me that z is 300. Okay. Make sure our answers make sense. Are these both positive? Yeah, right. We're talking about file cabinets. So what does this mean? So it means that our office manager, so he should buy, right, 8 of the ACE cabinets, not chemicals. So ACE cabinets, and 3 excellent cabinets, right? And then Z is how many storage files space he's going to have, right? So he will have, not $300, 300 cubic feet of storage. Just barely fit that on my page. So he'll get 300 cubic feet of storage. It's not dollars. That was silly of me. Okay. So again, the goal here is to maximize these problems. We have a situation, we have constraints on what we can and can't do, and we have something that we're trying to maximize. Okay, so that's what the goal is here. We set up this lovely little table with our slack variables, do some math to get to here, and then you just should be able to read your answers off that table. Okay, so that's kind of the big focus of this one. And again, our next lesson, we're going to look at how do you actually perform this step.